Hello, welcome to Let's Make It. And if you're a regular viewer, you know where I'm at. I'm actually sitting out in the control room like I was last week. But if not, normally we were in our own another studio in the other room. But this week we're just going to wing it out here. So I do have a couple updates I want to give you this week, and I want to show you some things that I worked on over this past week as well. This is episode number 60 or 70, 70, and it was recorded. And today is September 6th. And we record a show every Monday night at 9 p.m. So you can come watch us live, and we actually have a number you can call in and talk to us now. And I'm normally joined by my co-host Bob, but I'm not sure I'm going to be tonight, so I haven't heard from him to be sure if he's coming or not. But I'm waiting for him, and we'll see if he shows up or not. So the reason that I'm out here, I want to show you this real quick. Let me hop over here and we'll show you. This is our drop cam as in the studio where we normally are. And you see the tables kind of pushed off to the side. You can barely see the table. But we have a microphone set up because we've been doing some audio recording. So that project will go on for probably another week. So probably next week, I'll still be out here at the same place. If we get done early, I won't be. But the next week, then I'll be back in that studio. So, but for now, I'm hanging out here in the control room. And I don't have an overhead because I actually wanted a product camera today. So I took another camera, and I can't show you the overhead. It's out here. I took that camera and made it the product camera. So I will be able to show you some things today that I couldn't do last week very easily. In fact, I'm going to go back and show you some of the things from last week. But let's kind of catch up a little bit on what's happening this week. So last week I showed you some ink, conductive ink. So it comes like this. You can paint with it, and also came in a little tube like this. And it came with a touchboard, which I'm going to go through and show you the touchboard and actually listen to some things that it does, and we'll talk about that a little bit. But since then, I got another Kickstarter project. Now it came with 4 pens, and actually 5 pens. There's one in the container, and I might have one actually make them with another one. I think it's over there sitting, but it comes in this thing, and it came with 2 batteries and a little LED light. I'm going to show you it's conductive ink. Now I've had a little bit of an issue. It takes quite a bit of ink. You just can't draw a line. You got to take and you got to like scribble a line to make sure that it's all conductive to get to work. But I did get it to work, so I'll show you that in a little bit too. But it came with 4 pens. So it's kind of cool. You can draw a circuit, and it came with a little LED that you can put on in 2 batteries, and I'll show you how you can connect them up. So similar in concept to this black ink that's over here. This is very silverish though, so I'm not sure how it's going to come up on camera. It's kind of light. When I first started writing, I thought it was actually just indenting the paper until I realized it was putting down ink. It's that light. So let's see. I'm going to talk a little bit about. Let me grab this real quick. That's the problem because the camera's way over there. I'm going to start talking a little bit about 3D printers also in a couple weeks. So I got my 3D printer working. This is actually a Raspberry Pi in the Raspberry Pi case that it's been printed in my 3D printer. I've had a couple other things, fun things, like here's a little cube. Actually, let's try the product camera out. Oops, wrong one. There you can see it's just a little cube. A little bit interesting of a cube. I mean, you can see it 3D printed pretty decently. There's still some tuning to do on the 3D printer. It actually takes a lot of tuning that I didn't know about. This camera does not focus very well. So, but there's one thing I'm actually having a problem with right now. You can see, I can show you this, and I'm not sure what happened because this was working. Where's the one that's has the words on it? Oh, there it is. So if you look at this, you see all the little lines in there, but look how thin the walls are. You can read the SD card, but then right after that, you see it starts breaking up. So I'm having that problem, and I'm not quite sure what's causing it. So here's another one that started printing again after I thought maybe I fixed it. I took the extruder apart and cleaned it and made sure things were working okay, or I thought it was working okay. So, but then I did print this one, which is one that I designed, and this is actually for mounting a Arduino Uno on, and this is actually part of the case I'm designing right now for the doggy button that we talked about a few weeks back. And I'm trying different software, still trying to learn the best software for doing this kind of stuff. I did this in SketchUp, but SketchUp I can't figure out how to do this. It may actually do this to give it an exact location. Like I know exact millimeters I want from the edge of the board for the holes, and I can't figure out how to do that. Now in 123D Design, I know how to do that. So I did draw this also in 123D Design, but I wanted to figure out how SketchUp worked. But what this will be is it'll be, if I decide to 3D print it, which I may cut it out of wood using a laser cutter, there'll be this and a place to mount the speaker, and then there'll be a hole for on the top of it. This will be the bottom of the case, and then there'll be a speaker somewhere, or I'm not sure, I may mount the speaker like this on the side of the case. I'm not sure yet. But this will all be in one big print. This is just a test print to see how hard it is to design in SketchUp. Now you can see here, see how thin the lines are? It's solid. I mean, it's thick and it's solid, so it's not like it's gonna break or anything. But my prints prior to this would have been solid looking, not with these lines in it. The blue lines are me, because as part of the debugging process, I was taking a blue Sharpie and marking the material to make sure it was moving. So you see these blue lines when it actually melted the material where I had the blue one to make sure it was moving. But that's another thing I worked on. And actually, I did print another Raspberry Pi mounting case, which actually I'll show you here in a second, and another picture. Let me come back over here, and let me get the pictures up here. Let's see. That's not the one I'm looking for. Yeah, so let's do this. Let's bring this back to full screen. And this is a waterproof box, and this is part of the B project. If you've been following along, I'm actually working on a solar-powered B monitor. So, and I think I've shown you a couple pieces of this already, but this is where it's starting to come together. This weekend, I probably will cut out the wood inside. So I was doing it now, I was measuring everything, kind of see how it all would go together. But what you see in there is you see a battery down the bottom left, and then you see a solar charge controller and a Raspberry Pi. But you see the thing the Raspberry Pi is in, that white thing? That's actually something I 3D printed that will screw to the back of this case. So let's see, I think there's another one here of this. Yeah, here's a different angle of it, so you can see the case a little better. It's a pretty good size waterproof container. So you can see that right there. I'm going to go down to these pictures a little bit. See what's the first one here. That's good to buy. Oh, yeah. Hexacopter. This is what happens to hexacopter when you hit a tree about 60 miles an hour. You see the broken off limb there. So I haven't had a chance to fix it yet. But the only thing that broke was the arm. I mean, everything else survived. No broken blades. I have a motor that gets stripped out some wires. I probably will put a different motor on just to be safe. But it feels like it's spinning just fine, but when you're holding it. But the hexacopter project is still undergoing. I need to still edit some more video and work on the other ones. I think as winter comes along and I'm inside a lot more, that'll start to change. But you see the arm hanging down there, and unbelievably the rest of the thing is pretty much intact. The landing gear and the camera fell off, but they weren't damaged. They just fell off. I did crack a battery as well, and it didn't blow up or catch on fire, so that's a good thing. But it hit a tree, and the battery probably flew 50, 60 feet, and landed. And I was doing some experiments with it that I think I was trying to use two batteries, and instead of getting the two batteries to mount, I think I turned the GPS antenna so it didn't know which direction it was really going, and tried to correct. And then when it did that, when the batteries fell off and hanging over the edge. So in its attempt to correct itself, it actually ended up hitting a tree probably about 150 feet away, going very, very fast. And I actually have a video of it. It's kind of funny. You see it all of a sudden take off from the house, and boom, it hits a tree. So, all right, so let's see what else we have here. Oh, okay, so this is part of the B project. I took some pictures of this stuff. I want to make sure I wanted to talk about it. This is a stand that I am making. I have two pieces to put in yet from here to here. And on the other side, that is PVC, and it actually will hold the solar panel. It's a full-size solar panel. And then on the back here is where I'll mount that box. These are the same distance apart as the mounting holes on the box. So I can just drill a hole straight through these and mount that box. It has threaded bolt holes on the back and the outside. So they don't go to the inside of the box. The box truly is waterproof. There will be no hole in the box. With the exception of, I have some grommet type things that are used to put wires through a box waterproofly. I can't remember what they're called. But so there's that. Oh, okay. And here's the other thing. And next I'm going to show this here in a little bit. my ADSB antenna that I built a long time ago, I finally got it outside and I put it on the same pole where the weather station is. So inside this little box, I'm going to get a better picture of it here somewhere. Yeah, inside this gray box, there is a Raspberry Pi and an ADSB wireless dongle. And this is the 12-segment ADSB antenna. You see the weather station there. There's a better picture of it. So I got amazing distances out of this thing now that I've moved it out to above. This is probably about 25 foot above the ground. It's close to the top of the house because it's actually down the hill a little bit, but it's getting a lot better to our east, which to the east we have a little mountain, and this helped a lot. We have a house also on our hill, goes up, keeps going up a little bit farther. There's a house up there. So just a little bit of raising it's gotten me out there. I can actually see out into the ocean a little bit, where before I was actually losing it. They could go right around Washington, D.C. area, or just slightly east of there, depending on how high the plane was. So now I'm seeing planes that are going up the corridor towards New York City. But we'll show you a little bit of that in a little bit here. And then the other thing I'm going to show you here is a video, and this is kind of like what I've been doing for the last couple of weeks and keeping me busy. And how we explain, but basically I built an electronic workbench. And I went from 2 small desks, which you've probably seen pictures of, like when I was doing the ADSB antenna. If you watch some of the older videos, you'll see me working at the black desk. And it basically was a computer desk and 2 small pieces of it. I ended up building a standing electronic bench. And you can see the soldering irons and everything there. But you see all those black cases that are up on that shelf? Those are the H3J products, and those are all orders that I need to put together. And so building this and testing out some new boards, which you'll see sitting around there on the table. And then there's the oven for doing the cooking of the boards when you do the surface mount stuff or the reflow soldering. And boxes of stuff, which is basically parts for those. And there's a box full of green PC boards there. A computer for testing, and there's a CNC machine on the right there. So this has been keeping me busy for quite a while. Especially for the last few weeks, getting this stuff put together, plus trying to fulfill orders. So it's partially part of the problem why we've been a little scattered with shows, but this is actually done. This desk is done now, and the process is the boards have been all tested but one. I have one more test yet, and they're all worked fine. So we're gonna continue on building the rest of the products. The buttons are up here, and there's a whole bunch of Arduino boxes in here. So, and like I said, there's the oven, the CNC machine. But it was a nice improvement. It gave me a lot more space. It cleaned up my office, which is where the desk was before. This is actually out in another room. It's right outside my office, but still very close. And it's still very close, so I can just go back in and out. But it allowed me to get a lot more space with the shelves and a little bit more organized. I know it's kind of a mess at the moment. That's just because it's a work in progress and still working on things. So that's what's been keeping me busy. In addition to everything else going on, like in the studio and everything, like I said before, lots and lots of stuff that's going on. All right, so what I want to do is I'm going to hop over to the product cam, and I'm going to unmute. Oh, that thing's really noisy all of a sudden. I'm going to unmute the box that has the touchboard on it that I showed you last week, and let you hear what it sounds like. It's very noisy. As far as a board goes, and I don't know why that is, and it's even noisier now than it was before. I'm seeing it click out of the corner of my eye, so I have it muted, so I'm going to have to unmute it. But we're going to go back over to the product cam, and I'm going to grab that, and we're going to talk about it a little bit. So let me hop over there real quick. And as I do that, you're going to hear me moving around. Sorry about all the noise. Okay, so I do have the touchboard. Let me unmute it. There you go. Hear that noise? Great. Such a lovely noise. I'm not quite sure why the noise. So here's the touchboard, and it's plugged in right now, and each of these down here has a different sound attached to it. So I'm going to play one.
The touchboard uses the Arduino programming environment. The board also features the Arduino Leonardo pin layout, so that you can attach headers and plug on Arduino shields.
All right, and you can hear the noise. It gets even worse when she talks. So let's go touch the first one here.
Congratulations! If you're hearing this message, your touchboard is live. The touchboard has lots of interesting features, and we're going to tell you about them, so press the next electrode to continue.
We'll continue down the electrodes.
The touchboard has 12 electrodes numbered E0 to E11 that behave like individual sensors. These are inputs that trigger sounds when you touch them. So you've clearly got it working. But don't forget, you can play audio through headphones or speakers, and you can power the touchboard from either a micro USB cable or a rechargeable LiPo battery. So you want to make a dog bark piano or a cookie jar siren? No problem. You can easily change the sounds on the touchboard. Audio files are stored on the micro SD card. Always disconnect the power first, then pop out the micro SD card and plug into a computer. New files must be in MP3 format and use a special naming system that assigns them to an electrode. To find out more about this naming system, check out the README file on the SD card.
Alright, I can't do this without...
The reset button is your friend. It's a tiny button located next to the clipped corner at the bottom right of the touchboard. Every time you connect something new to the electrodes, you need to recalibrate the board. Press this button, wait for the red light to stop flashing, and you're good to go. Now the fun part. You can extend from the touchboard to create sensors anywhere. Connect something conductive, like a wire or paperclip, to electrode E0. Press the reset button to calibrate, then touch the wire or paperclip and see what happens.
We're not going to do that right now, but just wanted to show you what, I'm going to keep on going. There's only 4 more to go, so.
Why stop at 1? Try connecting to a few electrodes using the examples shown on the box. You can use conductive thread, tin foil, copper tape, alligator clips, wire, paper clips, the conductive foam in the box, electric paint, or anything else you can think of. Electric paint provides a great way of creating graphical interfaces with the touchboard. You can paint directly to the electrodes and use stencils or even screen printing to bring your images to life.
I did not know the foam in the box was conductive. I'll have to go grab some of that and see and check it out. Let's keep going here real quick.
The touchboard uses the Arduino programming environment. The board also features the Arduino Leonardo pin layout, so that you can attach headers and plug on Arduino shields. To all you advanced users, why not replace the touchboard code or write your own? You can turn the electrodes into distance sensors, use the touchboard as a MIDI interface, set individual electrode thresholds, output a continuous stream of electrode data, or set up the touchboard as a human interface device. This is only the beginning. Check out the dark side of the touchboard. It's perfectly flat to easily integrate onto all your projects. You'll find 2 mounting holes beneath E0 and E11, and a plated hole at the bottom left corner in case you need to attach it securely. By the way, the 3rd hole also doubles as a ground.
Alright, and the last one.
You've reached the end of the touchboard tour. If you'd like to find out more, there are detailed instructions and great project ideas at bearconductive.com. Get in touch and let us know what you make.
Alright, and I'm going to mute that because that is a very annoying sound. And I'm not quite sure why it's so noisy, and it actually got worse when I changed the input power source. So I'm just thinking it's not, it just doesn't have a great filter on it or anything. So let's see. I'm going to go ahead and do the other one while I'm sitting here. So let me go get this out of the way. I'm actually going to unplug it so it's out of the way. And this is what came with the Kickstarter with the pens. So you see, I'm going to get back over here again. I'm going to have to kind of use 2 hands to do this. It came with this, which basically is a dual color LED depending on which way you hook it up. The pen, I did this with the pen. You can see it pretty good on camera. I thought you would not because it's pretty light looking. But that's the conductive ink that's in the ink pen. And it came with 2 batteries. So what they tell you to do is take the 2 batteries and put them on a spot like this, and then bend the paper over, which I'm going to do. just like that. And then you take these. Oh, it ain't gonna work. There it is. And that's red that direction. And if I turn it around like this, it's hard to do on camera. There it is. And then there's blue. So you turn it around. So that's all done by paper and ink. So they actually had this as a kit somewhere. I think it was this one where they showed that I think they were selling this type thing like this right here, but with like resistors and capacitors and other things on them, so kids could learn how to draw circuits using that. So I thought it was a cool idea when I got it. I didn't like getting that stuff though. It must have been extra. I don't remember what all I got. I forgot I had two things coming that had conductive paint in them. So until it came, and it was funny that it came the week after I got the other thing, the touchboard last week. All right, so today's show is actually going to be pretty short. I'm pretty much done, but I do want to talk about a couple of things that are coming up. Next week, I'm going to do an episode all on LCDs because we keep getting this question over and over again. People have a hard time getting serial LCDs to work and find the right libraries. And it is a complicated subject because there's so many different things out there from different people. But really, after we explain it, I think it'll be a little bit easier. And I'm going to give you some tools to help you figure out what you have and what you don't have. And a particular chip as well that almost all use. And we'll talk about that. I'm also going to show you a touch screen LCD hooked up to the Udo. And the Udo is running Android, I think, right now. And we'll show you that Android working on Udo as well. And then the week after that, I'm probably going to do a whole segment on the Galileo because there's lots of confusion about the Galileo, the Arduino Galileo. For the most part, it runs like an Arduino. However, it's not an Arduino. It's actually an Intel chip that is emulating the Arduino, which causes a whole bunch of things that are problems. And sorry, I saw something blinking on the corner of my eye up there. It's hard sitting out here in the control room. There's a lot of things that we found. We are starting to use this in some of those boxes that I was showing you out there in that video. And this is our controller, and we had to develop a special breakout board because of limitations that it has and some things that it does to make itself like an Arduino. It's truly not an Arduino, and there's things with memory space you got to be careful of. It is really running Linux when it boots up. Takes it a while to boot, a lot longer than what the regular stuff does, but it gives you a lot of stuff you can do if you put an SD card on it that you can't do on a regular Arduino. So it has a lot of benefits, but it has some problems as well. If you're used to you just can't take your code and upload it and assume it's going to work. If simple things like Blink or things like that will probably work fine, but things like we were doing with I2C and networking and all that stuff, no such luck there. It took us a couple weeks to actually get to work. And had to change some things how we were doing things, and in the end, it became an advantage to us because instead of using a standard I2C, which is basically 128 addresses on the 7-bit bus, we actually went to 4 times that. So we can do 4. Well, actually, what is it? Be more than 512 addresses on the I2C bus, so we can actually address the way we went to it. So the way we implemented it. So it actually was in the long term a great advantage to us going this way. And besides the fact that it's slow to boot up, if you get past the other problems, it's actually a pretty nice board. It has some nice expandability type things you can do with it. The boot up is something I wish they would somehow fix that and make it a little bit faster. But it being Unix, I mean, we've actually tuned it down better than what the default is. We actually have changed the boot cycle a little bit and some of the delays that it waits for. Because when it first boots up, if you've ever heard of grub on Unix, if you run Unix, the first 10-second wait is there by default. And we took that out and said, don't wait, and we get rid of everything else in the grub menu, so it just went straight on through, never stops. So we saved like 10 seconds of the boot through our configuration. But it's the kind of thing I want to talk about because it has a great potential to be a really outstanding board, but you just can't assume it's an Arduino. And there's a lot of gotchas, and as I look around and I see people get this thing because it's the new Arduino, and their sketches don't work, and there's some quick things you can do to fix a lot of that. and we can walk through that. And a lot of times it's just memory-based because it's not an AVR chip anymore. It's actually an Intel-based chip that's running a simulator or emulator for Arduino. And so we'll talk about that, and we can go into pretty good detail. We've gotten pretty good at working on that stuff now. But I just want to go ahead and answer a lot of the questions. But I want to take first next week and do the LCD episode because I'm literally getting 2 to 3 emails a week right now asking about LCDs and libraries. And it really typically is a fairly simple thing to figure out. But I think if we walk through and we explain it, that it'll help solve some of this, and it will provide you some tools that will help you figure out how to figure it out on your own by downloading a little sketch, and it'll tell you where your LCD is and then how to access it as well. And we'll talk about different types of LCDs. We've been experimenting with some different types of LCDs as well, and we'll bring that. I'm going to show you a touchscreen. And we actually have our own LCD backpacks now. So because of all these problems and there's no consistency or no documentation anywhere, or sometimes you get something that conflicts with another device, which is also happening quite often, and you can't change the address on the LCD. We've developed one that you can change the address, but we give you documentation on what it is by default, give you the library, and you can change its address real easily right on the back of the board. Just got to put some jumpers on the address pins. So we'll go through all that next week and talk about, if you have an LCD problem, how you can figure out what the problem is. So I think we're going to spend a good long time on going through that and describing it. Give you a little bit of history about it and some of the common problems that we've found through this. So we had the same problem when we first started. We didn't understand why certain libraries didn't work, but now that we've built our own and using the same chips, by the way, that everybody else does, we pretty much know how all that stuff works. And it doesn't need to be that complicated. I think it's more than anything lack of documentation and people fixing things in a particular way and not telling you how it's fixed. It's not a problem, say, if you want to fix it to a certain address, as long as you tell somebody what the address is, but nobody does it the same address, which is where all the confusion comes along. So we have a little scanner that I've written that'll go through. You plug in your LCD and you run it, and it'll tell you where the LCD is, and you just change that address line in the LCD line, and it goes. So, but that's all going to happen next week, and hopefully Bob will be back next week. Haven't heard from him tonight, so I don't know. I have to check in with him and see what's going on. Hopefully everything's okay down there. All right, we'll see you all next week. For show notes for this show, contacts, and more, go to the techzen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.